Okay, folks, so I want to look at solving this system of equations, and we're going to do it using the Laplace transformation. So I'm not going to review how we do any of these individual Laplace transforms, nor how we do the inverse transforms. I'm just going to jump straight into it. So what we're going to do is we're going to take the Laplace transform of both sides of this equation. And we had a theorem that said how we would take the Laplace transform of derivatives of some function. And we learned that that would give us, in this case, we would have for the second derivative s squared times the Laplace transform of y, which we'll just call y of s, minus, in this case, s times y0 minus y prime 0. And that all would be the Laplace transform of just y double prime, plus 3 times the Laplace transform of y prime, which would be sy of s minus y of 0. Then plus 2 times the Laplace transform of y, which will be 2y of s. Remember, all those constants came out, and we distributed in the way we did because the Laplace transform is linear. On the right-hand side, we get the Laplace transform of e to the minus 3t, which is 1 over s plus 3. I'm not going to review how to do that, but you could take a look at some earlier work. So what do we start doing? Well, we can start plugging in our values for y naught and y prime naught, and we'll go ahead and also collect some like terms here. So I'm going to collect together all the s term or y sub s terms. So we've got s squared plus 3s plus 2 times y sub s. That was grouping together this term, and this term. Being careful to distribute as we need to. And then we get minus s times y naught. So that's minus y naught is 2, so that's minus 2s. And y naught prime is negative 1, so careful, watch your negative, that's plus 1. Plus, well, 3 times negative y naught, so that'll be minus 6. Double check that distributive step. Thanks for interrupting. Trouble checking that distributive step. And then we have that's all equal to 1 over s plus 3. So cleaning things up, we get s squared plus 3s plus 2 y sub s. And we'll take all the other terms over to the other side. I'm going to go ahead and combine this 1 and negative 6, so we end up with 5 plus 2s plus 1 over s plus 3. So the next thing we're going to do is solve for y sub s. So we get y sub s is equal to 5 over, and factoring that expression, we get s plus 2 times s plus 1 plus 2s over s plus 2 times s plus 1 plus 1 over s plus 2 times s plus 1 times s plus 3. Okay, so now we've just sort of got a mess that we're going to have to resolve by using partial fraction decomposition so that we can then do the inverse transform of both sides of this equation. So let's go ahead and calculate that. Using our tricks where we say, hey, one way to evaluate this is for the coefficient over s plus 2, we say, okay, if we plugged negative 2 into the expression 5 over s plus 1, what do we get? And that would be minus 5. And doing the same thing, breaking this up accordingly, over s plus 2, we would have negative 4 all over negative 1, so that comes out to be 4. And plugging negative 1 into the expression, let's see here, that would be 1, so that's negative 2 over negative 1, which is plus 2. Oops, negative 2 over positive 1, which is minus 2. And then breaking this up accordingly, let's see here, we would end up with over s plus 2, we would have 1 over, let's see, that's 1, and that's negative 1, so that's minus 1. Let's see here. Then if we check for over s plus 1, plug in -1, so that's positive 1/2. And if we plug in for s plus 3, if we plug -3 into the remaining expression, we would have -1 and -2. We also get 1/2 there. Okay. So folks, hopefully we checked that correctly. Okay, so let's go ahead and combine all like terms here so we can minimize how many inverse transforms we have to do. So we get y sub s and let's see here, we've got looks like 3 s plus 2 terms. If we combine them all together, I think we get -2 over s plus 2. And if we combine together the s plus, well, we've just got a single s plus 3 term, so let's just do that, s plus 3. And then if we combine together the s plus 1 terms, let's see here, I get -3 plus 1/2, so that's -6/2 plus 1/2, which is -5/2 all over s plus 1. And now we're ready to take the inverse transform of both sides. So we're going to go back the other way now, using the inverse transform. -2 over s plus 2 plus 1/2 over s plus 3, and plus -5/2 over s plus 1. And I'm not going to review how to do the inverse transforms here, but this gives us y of t is equal to -2 e to the -2t plus 1/2 e to the -3t, and then -5/2 e to the -t. Let me clean that up slightly. That was to the -2t. And sure enough, that is what you would get if you solved this initial value problem by any other method. I hope this made sense. If not, let me know.